Ko.
I can proceed.
Yebo.
All right.
Then I can leave.
Bye-bye.
Bye.
Okay. And a very good evening to everyone. For those maybe who are
Evening, sir.
joining, yes. For those that may be joining us today for the first time, my name is Namazavo Kone, and we are on our fourth lesson on integration, but it is on unit 5 because we did some of the 2 units together in one lesson. And this lesson it's a very interesting one because it helps us to get out of sticky situations, like when we have got a situation where we've got a denominator that is quadratic and a numerator that is a constant, wherein there's no connection between the denominator and the numerator. So we have to do some algebraic manipulations for us to be able to make the given function to be integrable so that it can be integrated in simple terms. All right. So the first thing that I thought we must look at is the rules that we'll be concentrating on today. If you have checked the previous 4 units, the key integration rules were integration rule number 2 and rule number 3. Irrespective of whether we are doing integration for polynomials, or we are integrating trig functions, or we are integrating hyperbolic functions, or we are integrating inverse of hyperbolic functions or trigonometric functions. Whatever was happening was that we were using predominantly rule number 2 and rule number 3. But this is one of the lessons that we may once in a while use rule number 2 and rule number 3. But today we'll concentrate on rule number 24 to rule number 29 of integration. So I thought it would be better for us to first have a look at the rules before we even attempt to answer any questions using these rules. These 6 rules still confuse me. I've been in this business for a very long time. I have been doing mathematics at university level since 2004 up to today. So you can imagine that there are some of you who have just started with Maths 2 for the first time this year. So I have done this for a very long time, but this that you are seeing on your screen now, they still confuse me. And you may find that as we go through this lesson today, you may find that I'm quoting a wrong rule. So I want you to be vigilant in the sense that you must be able to watch the following things that confuse me so that they don't confuse you too, even when you have got the information booklet. If you look at these rules on the left-hand side, this rule has to do with squares. The rule number, let's look at rule number 24 first. Rule number 24 says, is the integral of the derivative of f of x on top. If you remember, this derivative of f of x is what we have been talking about from unit 1, when I will highlight it in red all the time, that it must always stay there for us to be able to do integration of the function f of x. Now, in this case, it is playing the same role. But now our f of x is not sitting normally like we know in rule number 2 and rule number 3. In rule number 24, if you can look at it, it says the derivative on top divided by the square root of the difference between two squares. And the square on your left is a number. It's an a squared. A is just a number. It can be a decimal, it can be a fraction, it can be even, it can be odd, but it's a positive integer. Not integer, not positive real number, because it can be a fraction. minus f of x in brackets is squared. So our f of x is here inside a square root sign, also inside an expression a squared minus f of x squared, and also inside that bracket where it is squared. So it is not sitting properly like it does in the rule number 2 and rule number 3. If you remember rule number 2 says the integral of f prime of x, and in brackets f of x raised to the power of n dx, and it makes f of x to behave like a variable where f of x can be treated as an x raised to the power of n. When you say on n you add 1 and you divide by the result, so f of x can behave like that. But in this case, something very different is happening. If you check the right hand side of rule number 24, you will realize that if you can be able to express the left hand side as a derivative on top, underneath there is a square root of a squared minus f of x squared, then the integral thereof is arc sine of f of x divided by a plus c. And if you remember, arc sine is found in trigonometry. Arc sine is also written as sine inverse. So it's the sine with the power of minus 1. So for us to be able to understand this similarity of writing or this difference in writing arc sine, we will have a rule that will have arc sine, and when we apply it, I will use sine inverse so that people must never forget that this is exactly the same. So this is the inverse of sine of f of x divided by a. And the a on the right hand side is that number inside that square root, which is squared there. So it must come on the right hand side as a as an integral as the denominator of the function f of x inside sine inverse, and then plus a c. That's how it works. Now the confusion, this confusion happens to me. It may not happen to you, but I will tell you what confuses me. If you look at rule number 24 on the screen, and you look at rule number 28 on the screen, the only difference between these two rules is that 24 has got a square root and 28 do not have a square root. But everything else look exactly the same on the left hand side except that square root sign. But when we go to the right hand side, rule number 24 is arc sine. Rule number 28 is 1 over a arc tan. So that is where people can get confused. So when you want to look for which rule you are applying, you need to be very careful whether you are applying a rule with a square root sign or without a square root sign. Look at rule number 25. Rule number 25 does not have a square root sign, and is the sum of two squares. But if you can check rule number 26, rule number 26 is also the sum of two squares, but the rule number 26 has got a square root sign. The one that does not have the square root sign, which is 25, is 1 over a arc tan. The one that has got a square root, but they look almost the same except the root sign, the right hand side is arc sine of f of x over a plus c. So that is the confusion that I have, which I hope you don't have. But if you do, I have given you a forewarning about it, so you will be able to be careful when you are looking for a rule that you should apply. So before I move to the next slide, these are just discussion of rules. Is there anyone who would like to ask a question or who have got a comment about these rules before we move? It means that there is no one. Now, in this slide, if you have realized that in the previous rules that we have shown you, all of them have to do with either the sum of two squares or the difference between two squares. So it means that there may be a situation where the denominator, which may be either inside a square root sign or outside the square root sign cannot be manipulated into a direct sum of two squares or a direct difference between two squares on its own when you see the question. But the question can come as a quadratic expression like you see on your screen. Y is equals to ax squared plus bx plus c. Now, if you find something like this in the denominator, you will have to perform what we call the completion of square, which I have requested you in the forum notification that I did during the week, that you must go through this method of completing the square in a quadratic function, because there will be situations where you will be able to need to do all these steps that we are going to explain in this slide. So what I'm going to do here is to explain to you, if you get an expression inside an integral and the expression is ax squared plus bx plus c, how do you perform completing the square, so that after you do this process, you get either a squared minus f of x squared, or f of x squared minus a squared, or f of x squared plus a squared. All of this will either be having a square root sign or not having a square root sign. But the process of completing the square is the same throughout. Now, there will also be other questions that you will not need to complete the square, because it will be given in such a manner that you can be able to write what you are given in terms of either a squared plus f of x squared without completing the square, or f of x squared plus a squared, or f of x squared minus a squared, or a squared minus f of x squared. There are situations like that, which means the kind of questions like that will be easier and they will be awarded less marks. When you have got a situation where you've got a quadratic like this one, there will be more marks, because there is a lot of effort that you are supposed to put into the solution by first completing the square. Now, this is how you complete the square if you are given an expression like that one, ax squared plus bx plus c. For you, it will be revision, because I hope you have done this before, maybe in high school or whatever. But if you have not come across this kind of method, you have to listen attentively, because you will need this skill for all the questions that will involve a quadratic in a denominator. First step of completing the square when you get an integral that has got a denominator that is quadratic is what is just highlighted there on the right hand side. So it means that you are going to just isolate c, put c aside. Don't group it together with any other thing. Just leave it alone, and you group together ax squared plus bx. And then after you do that, you factor out the coefficient of x squared. And if you can check this expression that you have, the coefficient of x squared is a. So you will isolate c aside, take ax squared plus bx, and you take out a common factor of a only. And when you do that, you will get something that looks like what is in the screen here. I don't want you to let me pass to the next step if there is something that you have got a query, because all these steps you will need to be able to do them on your own when we deal with questions today. So this that we have now as a second step, if you take that a and multiply it back inside the brackets, you will get back the original equation, because a times a squared is ax squared. A times b over ax, the a's will divide each other out and you will be left with your bx, and then the plus c that was outside will be remaining like that. So these two things are exactly the same. So the key here, the most important part, is you don't involve the c, which is the constant. The number that does not have an x does not get involved at all. Then now, this is the most important part of this process. And I am getting that I am left with 5 minutes in this meeting, which is very weird, because the meeting was supposed to have been from 6 o'clock to 8 o'clock, not to past. So we will just go on, even if the meeting was set up to finish at 8:30, 6:30. Right. Now, this is the most important part of completing the square. Now, we want to have what is in this bracket to become a perfect square. Now, for it to be a perfect square, we need to add the square of half the coefficient of x. Now, looking inside the bracket, the coefficient of x is b over a, and half of that is b over 2a. We need to add the square of that. So we need to take b over 2a, we square that. When we square b over 2a, we get b squared over 4a squared. That is what we need to add inside this bracket. Come again. Whoever was having a voice, if you have by mistake switched on your mic and you were not talking to us, please switch off your mic so that everybody else can listen without disturbance. But you are allowed to interject. So if you switch on your mic, you must say something. I will keep quiet so that you can get the question or the comment so that you can proceed properly. Thank you so much. Now let me repeat this quickly. I am saying for us to have what is inside as a perfect square, we need to add half the coefficient of x. And that half the coefficient of x must be squared. So we're taking b over a, and we take half of it, and half of b over a is b over 2a, and we square that. The square of that must be added inside this bracket. Now you will agree with me that when you add that square inside the bracket, you have changed the previous equation. It's now a new equation because it has got something foreign that has joined it, which is b squared over 4a squared. Then we must counter by subtracting this b squared all over 4a squared on the outside. So now if you look at this bracket, if you multiply this a inside now, you will have your ax squared that you had in the original equation. You will have your bx that you had in the original equation. Now the new foreign object that came is b squared over 4a squared. When you multiply this a with that foreign object b squared over 4a squared, you get b squared over 4a. That is why outside there on the c, you subtract that amount. When you add a value and you subtract the same value, it means that your equation is still the same because you have added a zero in a way. This is a very important part. We have added in the square of half the coefficient of x. What is half the coefficient of x? Is b over 2a. What is the square of that? Is b squared over 4a squared. But when it is inside this bracket, it has got an a that is outside. That when it multiplies inside, the b squared over 4a squared becomes b squared over 4a. That is why we have subtracted that value from the c that we have already. And it means that the equation that we still have here is exactly the same as the equation before, the same as the original equation. Now, there may be people who may want to know, why are we doing this addition? And how did we decide we must add half the coefficient of x squared? So is there anyone who would like to know the reason why we are doing this? If not, then we'll continue. I need to hear from you. If there's anyone who feel that they don't understand why we have to add that value. The value we are adding here is half of the coefficient of x squared. If you keep quiet, you are one of those that will want to know why.
Yes.
Ne? Good. So I am going to show you something. So that's something that I have got on the screen now. Is an example of three different equations. The first one is y is equals to x squared minus 6x plus 9. And when you factorize it, it becomes x minus 3 squared. The second one is x squared plus half x plus 1 over 16. When you factorize it, is x plus 1 over 4 squared. And the other one is x squared plus 10x plus 25. And when you factorize it, is x plus 5 squared. Now, I want to give you time, 2 minutes, to have a look at these three questions and tell me what you see as the connection between the coefficient of x and the constant that is there on each and every one of the equations. Look at the relationship between the coefficient of x and the constant on the three equations. And then after 2 minutes, I will want you to tell me if you see any pattern. Anyone who can tell me what you can see as the connection between the coefficient of x and the constant? The hint is on the factorized version. Anyone who can see a pattern from these three given equations? The connection between every coefficient of x you see there and the constant. In the first equation, the coefficient of x is minus 6. The constant is 9. In the second one, the coefficient of x is half. The constant is 1 over 16. In the last equation, the coefficient of x is 10, and the constant is 25. What is a pattern that you see there?
Can I give it a shot?
Yes, please.
The constant in each of the cases is half the coefficient of x squared.
Every constant you see here is the square of half the coefficient of x. And that half the coefficient of x is in the bracket that is on the far right side. So half the coefficient of half the coefficient of x in the first equation is minus 3. And the factorized version is x minus 3 squared. And minus 3 squared as it is 9. Half of half is 1 over 4. 1 over 4 squared is 1 over 16. And you can see on the factorized version, 1 over 4 is the value there. On the last one, the half of 10 is 5. And x plus 5 squared is the factorized version. And the constant is 25. 25 is the square of half the coefficient of x all the time. From studying the patterns like this, which gives us what we call a perfect square, all these expressions that you see here are called perfect squares because when you factorize them, you get two brackets that look exactly the same. The first one, the two brackets, x minus 3 into x minus 3. The second one, two brackets, x plus 1 over 4 into x plus 1 over 4. The third bracket, x plus 5 into x plus 5, which all can be summarized as x plus or x minus whatever number squared. So because of that, that is where we get this energy and power of saying whenever you want to do a perfect square, whenever you want to create a quadratic which can be factorized such that the two brackets look the same, the order of values should look like this. The first one must be an x squared. The second one must have a coefficient. Whichever coefficient that you have, you don't have to worry about that. You just take it as it is, multiply it by half. When you have got the result, square the result, add it onto the expression. When you have done that, you have created a perfect square. From there on, when you want to factorize this perfect square here will be x plus b over 2a into x plus b over 2a all the time. That is how we come to this conclusion. And is everybody now happy why we are adding the square of half the coefficient of x?
Yes, sir.
So we can move now.
Yes.
Right. Now, when we move, what we just did here is to factorize the bracket x squared plus b over ax plus b squared over 4a squared. And we factorized it like I've been explaining. Now, if you don't believe me, you can take this x plus b over a and multiply it by itself, x plus b over 2a. You would end up having what is in the previous bracket there. That's how it will go. So, I always tell my students that you guys believe you believe in a lot of things. With mathematics, the good thing about maths is that whatever I tell you, you can prove it right or wrong. So, in short, if you take x and you multiply by x, you get x squared. If you take x and multiply by b over 2a, you get bx over 2a. You take b over 2a multiply by x, you get bx over 2a. You take bx over 2a plus bx over 2a, you add them, you will get that. Because you will get 2b over 2ax, which over 4, you will get b over 2a x, which is exactly this that you are, in fact, sorry, bx over 2a plus bx over 2a. If you add them, you will get 2b over 2ax, which gives you b over ax, which is the middle term. Then when you square this one, you will definitely get that one. So then here, that is why this method is called completing the square. So that whatever you have here can be factorized as two brackets that look exactly the same. Whatever residues that are left are captured here in this thing. Now, for those that are mathematics fundies, will remember this thing. In quadratic equations, you will have something that is called, the quadratic equation have got three versions. The first version is the normal version of the quadratic function, y is equals to ax squared plus bx plus c. That is the basic general form of a quadratic function. The second one is y is equals to a into x minus x1 into x minus x2. That is what we call the intercept form of a quadratic equation, where x1 and y1 are x-intercepts in a quadratic graph. Can everybody switch off their mics, please? Then the last one is y is equals to a into x minus p squared plus q. If you remember that one is called the turning point form of a quadratic function. Now it is this one that you see here. If you remember, when you want to find what we call the axis of symmetry of a quadratic function, you take this bracket, this one, put it equals to 0 and solve for x. When you solve for x, you find that x is equals to minus b over 2a. And that is the formula to calculate the axis of symmetry of any quadratic function. Now, if you can take that x is equals to minus b over 2a, substitute in place of x here, you will put it here, it will give you a 0 here, squared, which is 0, times a, which is 0. Then you will be left with y is equals to that. That 4ac minus b squared over 4a is the y coordinate of the turning point of any quadratic function. And also, for those that remember what we call the quadratic formula. The quadratic formula is a formula that helps you to solve for x if you cannot factorize. So it means that when they came to this stage, you just come here and put y equals to 0 and solve for x. Now, if you do that right now, put y equals to 0 here, then you will take this to the left-hand side, and on this side, you will be left with a into x plus b over 2a squared. Now, because this is a number, and when it comes to this side, it will become negative. Now, when it is negative here, you can apply this negative onto the numerator, and the numerator becomes b squared minus 4ac when it is on this other side. Then you divide everything by a. When you do that, you will get b squared minus 4ac over 4a squared. And now this one is x plus b over 2a squared. When you take the square root both sides, you will have on this side x plus b over 2a left. But because this is a number, you must have plus or minus. Because when you take a square root of a number like 9, the answer is square root of 9, which is either 3 or minus 3. So when you do that, then you get what we call the quadratic formula. That says x is equals to, this will become minus b over 2a plus or minus the square root of all this. It will be all over 2a because this one will be 4a squared. When you add the numerators, then the numerators will give you minus b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. It comes from this thing that we have just done today. But that is not our lesson today. Our lesson today is about creating this opportunity. This opportunity, if it is created, here we will have a number, here we will have a function of x squared, and this number, whichever it is, it does not matter whether it is a perfect square or not, it can be rewritten as a value to the power 2. Then we will have sum of two squares. If the sign here is negative, it becomes difference between two squares. If this number is on the left and this one is on the right, and this one is negative, the a is negative, then this becomes a squared minus f of x squared. So whether it has got a square root or does not have a square root, then it will direct us to exactly this the rule that we are supposed to use between rule number 24 and rule number 29. Then I think this is done and dusted. And we now go to, you requested me to use an example that is existing in your study guide. It's just that I will not conform to the way in which the person who have written the study guide did the example. But I chose example number 7. Remember in the previous lesson, I asked you to choose one and you were not choosing, and you said I can choose whichever I want, and I decided to choose example 7. So if you go to your study guides now, you will find that this is example 7. And this is how I am solving it. It is not exactly the same way it was done in your study guide, but the end product is exactly the same. So now you said I must do this, explain every detail, and then from here it will be you guys doing all the rest of the questions. I will just be a spectator. Then you will be telling me the solutions, and we will just verify using what I have done, what I have prepared. And this lesson will be very, very interesting. So now our example is the integral of 1 over the square root of 3 minus 2x minus x squared. And now, when you get a question like this, your expectation about rule number 2 and 3 would be that on top here, we must have something that can be connected to the derivative of what is in here. But in this case, it's a number 1. And there is no way in which the derivative of what is inside this square root sign can be connected to a 1, because a 1 is a constant, it does not contain x. If there was an x there, we would start now thinking about what we can do, because we know that the derivative of what is inside the square root is minus 2 minus 2x. And immediately there is that x. It makes us worry that there is an issue with this one, because if this one does not contain x, there's no connection between it and the thing it inside the square root sign. That is where we need rule number 24 to rule number 29. But we will now, I don't even know which of those rules I will use. But when I have done completion of the squares from this one, it will be directing me to a rule, either 24, 25, 26, 27, 29. So this is how you, if you get a question like this in an assignment or in a test, should do this question. First step. Now, I want to explain this first step. If you can see this first step, it just rewrites exactly what we were given in a different way. First thing, I isolated the 3. If you remember, when I was explaining the completion of squares in that slide, I said, first step, isolate the constant. So this is the step that I've just done here. The constant is 3. It does not have an x. So here it is here. Now, what I did was just to factor out the minus sign from these two values that contain x. Here is the minus sign, and whatever is inside, if we can remove brackets, multiply by a negative sign here, we get back to exactly what we have as given there. So which means this, what we have here, is exactly the same as what we are given there. So that is the first step. The next step, I want to create a perfect square. The main aim is to create a perfect square in here, in this bracket. So for us to create a perfect square, we follow the same rules that I explained at the beginning, that you go and find the coefficient of x, which in this case is a 2. Find half of that 2. Half of 2 is 1. Square that and add it onto the expression. So the half of the coefficient of x is 1, because half of 2 is 1. 1 squared is 1, which is this one that you see here. That is what we have added in this bracket. It was not there. So because we have added a 1 here, we have changed this expression. For us to still have the same two things to be called equal, when we say they are equal, they must be the same. So what we have added here, we must subtract here outside. Now the question is, what exactly did we add? If you remember, there's a minus sign outside this bracket. We added a positive 1 inside the bracket. If we remove this bracket, this negative will apply to this 1 as well. So which means that what we really added is a minus 1. That's why we have added a positive 1 to the 3 that was there already. This 3 is the one that was the constant from the beginning. So 3 plus 1, this plus 1 is compensating the minus 1 that we have added inside this bracket. But it looks positive here, but it has got a minus outside. So if you can take this negative inside now, this will become minus x squared minus 2x minus 1. And then bracket is not there anymore. This 1 minus that 1 will be a 0. Then you still have back your 3 minus x squared minus 2x. So this is how we did it. And now whatever is sitting here is a perfect square, which can be factorized. Now, when we factorize this perfect square, we get x plus 1 into x plus 1, which is represented by this x plus 1 squared. Now, the 3 plus 1 becomes a 4. Now, this 4 can be written as 2 squared, which is what you see there. So now this, when you look at this, I've deliberately put a 1 in red because 1 is the derivative of what is in this bracket. Our f of x is x plus 1. The derivative of x plus 1 is 1, which is this one. Now, I want you guys now, if you have done what I've requested you, which is the following, have rules number 24 to 29 ready, available for you all the time. Which rule is reflected by what you see on the screen now? Rule 24, 25, 26, 27, 28, or 29?
24. Rule 24.
24.
24. You all agree it's 24?
Yes, sir. Yes, sir.
Yes, if that is the case, then let's check. And yes, on the yellow there, you can see you are right. It's rule number 24. This is how you should. That is why the first lesson, if you remember, I told you that you guys are just not wanting to get distinctions because you are allowed to have the formula sheet. Those that are doing BSc are not having the same luxury as you guys. Because in BSc, there's nobody who will give you these formulas. You're supposed to be able to derive these formulas on your own. That's how we studied. I studied a BSc type of a degree. I didn't have the luxury of these formulas, and I took a struggle for me to be able to teach engineering maths, because for me, given these things, it didn't make sense. I should be able to do these things myself using all those U substitutions and so on that you guys are not required to do. Everything is given there on the platter. The only thing is for you to be able to start from what you are given as example 7, manipulate it, but you cannot manipulate things if you don't know where you are going. It's like if I can give you a car and I give you a blindfold wherever you are, and I say drive to Limpopo, then there is no, you are not going to even move. But if you know where you are going and I remove the blindfold for you is this thing in yellow here, which you are given. You get it inside the exam. So this is how you answer an exam question. And yes.
Roll number 24 doesn't have 1 over A at sign.
Outside, né? So I copied it
Yes,
wrong.
sir.
I copied it wrong.
Yes.
Yes. You see. That is why I say these things confuse me like crazy. So you see, in an example, I'm already confused. So can I go and correct that before we continue? Because I don't want any mistakes. Thank you very much. So it means there is no 1 over A in rule number 24. It's just arc sign, isn't it? So which means here
Yes,
on the
sir.
Tan.
Come again?
I think the 1 over A applies on tan when you're using tan.
On other rules. Let's just put it like that.
Yeah.
Yes. Right. So I'm telling you, these rules confuse me like crazy. So you can see the confusion even in an example. Because I didn't even check the answer in the example in the book whether it is consistent with what I did or not. I just did my own way, and now, so as you are saying, so this is the correct version.
Yes, sir.
So if that is the correct version, and now this is the correct answer, is that correct?
Yes, sir.
Is it consistent with example 7? Can we check example 7 and the final answer?
Let's check.
Check example 7 and check the final answer and see. Tell
Correct.
me if this is
Correct.
it correct?
Yes.
Yippee! I got it. I'm happy. Now I'm done for the night. Now the rest of the things that are coming after this is what you guys are going to do. Can we go to the first one of what you guys are doing? There you go. Can you do this one? And should we do this? Do this until you get to the final answer and you give us only the final answer. And then so that we can go through this very quickly. But if you are getting stuck, shout. Okay? So I will be timing you so that we don't waste. We need to finish this before 8 because that is the length of our lesson. So I will give you 3 minutes to get to the final answer and give us the answer. If 3 minutes ends and there's no answer, then I will start doing it. But if you get stuck when you are doing it, please shout so that we can see what we can do to assist you. 1 minute left.
Answer is
Yes.
minus 3/4 cos into
Cost, ne?
yes
Okay.
into x minus 3/2 plus c.
Cost or cost inverse.
Cos.
Or arc cost, yeah, which is
Yes.
cost inverse. Oh, okay. So, right. Do we have anybody who has got a counter to that one? It looks like people are not yet there, or you are the leader. They are agreeing with that one. And it's time up. Guys, shall we have a look together at the solution?
Yes, please, because me, I use a different.
What did you use? What did you use?
I did this. I take out 3, then I went down and do the completing the square at the bottom. Then I use U substitution. So I want to see if it's going to be the same.
Oh yeah, yes. If you use the U substitution, it should end up being the same. The bottom line is the final answer. You haven't reached the final answer yet in your side, ne?
Yeah.
Oh, okay. Let's see if you were getting there, because this is the. So what we are doing here, the formula sheet is your U substitution actually replaces the formula sheet, because you don't need the formula sheet for you to be able to use the U substitution, and that is how different pure maths and applied maths is in terms of this kind of things. So, but anyway, at the end of the day, we should reach the same place. Right. So, the first step that I did here, I hope those that are using completing the square have done the same. 3 is not part of this thing. It's just a decoy. So I took it out. And also in the denominator, I realized there's a common factor of 2. Take it out. It goes out as a half now because it is at the bottom. And then I isolate the value of c. After taking out a common factor of 2, what is left is x squared minus 6x plus 5. So 5 is isolated, and we group together x squared minus 6x. Then that 3/2, which is outside, has inside x squared minus 6x plus 9. This 9 is coming out of completing the square. We took half the coefficient of x. The coefficient of x is minus 6. Half of it is minus 3. And we square that one. When we square that one, we get a 9. Then what is in bracket is a perfect square now. Because we have provided a 9 inside the bracket, we must counter that with a minus 9 outside. That is where we get that. So if you can remove this bracket now and you add like terms, you will have 9 plus 5 minus 9, which is a 5. So the constant remains exactly what we have in the previous expression. From there, then we get to now the perfect square factorized. The version factorized is x minus 3 squared minus. Now our 5 minus 9 becomes minus 4. And minus 4 is the same as 2 squared. That's why we're writing it like this. Now I've written it like this with a 1 red there, because the 1 red there is the derivative of x minus 3. And now it is the time for you to go and look at the rules now. You check the rules. Which rule applies here? And you can confirm with me if I'm right, because as I have told you from the onset, these rules confuse me like crazy. So am I on the right track now with rule number 29? Is it consistent with what we have?
Correct.
If it's correct, then we are sorted. Then the answer is this one, which is now, to explain it, the 3/2 is what we had already, then according to the rule, it's supposed to be minus 1 over a. What is a? A is 2. So minus 1 over 2 is coming. It finds 3 over 2. 3 over 2 times minus 1 over 2 is minus 3 over 4. Cos inverse is the same as arc cos. So I'm just writing the different variations of writing this same thing so that people can know that this is exactly the same as that in terms of writing. And then our f of x is x minus 3, which is this one there on top, divided by a, which is 2, which is that one. And we are done. That's how easy these things are. Because you already, when you get into the exam, you've got this rule. It's there. So what you just need to do is, when you get an integral like that, the denominator is quadratic. First thing that you think of should be rule number 2 or rule number 3, saying, what is the derivative of what is in here? And you realize the derivative will contain x. Does this contain x? If the answer is no, then it means you must come to rule number 24 to rule number 29. In fact, you don't go to them yet. What you need to do is try and perform the completion of the square of the denominator. When you are done, when you're at this stage, then you go and look at the rule. It will just tell you, here I am, I am the match. 29. Apply 29, done. Do this one. Same kind of a question. Same 3 minutes.
Can I ask you a question?
You can, please.
Okay. Pretending your answer, I know we're doing hyperbolic function and stuff like that. When I used my formula, I got 3 over 8 ln absolute value of x.
Should I go should I, to the previous one?
Yes.
Oh, this one.
Yes. So I got 3 over 8 ln absolute value of x minus 5 over x minus 1 plus c.
Oh, did you use the u substitution?
Yes. Then I end up doing a partial fraction because I had to separate them.
Oh, okay. Yeah, yes. Here you can use, if you are using, can you tell me the fraction again?
3 over 8
Mm-hmm.
ln absolute value of, inside the absolute value, there's x minus 5 divided by x minus 1 plus c.
And that's it.
That's it.
All right. Can you tell me something before we go on? If you remove this, you remove a factor of 2 here. What we are left with is x squared minus 6x plus 5, right?
Okay, so I didn't remove the 2. I left my 2 at the bottom. So what I did, I said 3. Okay, can I WhatsApp you so that I don't confuse any to the others? Like tomorrow.
Yeah, you can WhatsApp me, because the issue is that if before you will WhatsApp me privately, it's fine. But I just want to express something that the others need to know. So if this one at the bottom can be factorized completely, which I doubt, if it can be factorized completely, this one.
So I did.
Can it be? Yes, I think it can be factorized because x minus 5 into x minus 1, right?
Yes, so it's 2 brackets, x minus 3 squared minus 8. That's what I ended up having in the denominator.
Wait. So this is what we are having: x squared minus 6x plus 5. And if you can take this one and it is x minus 5 into x minus 1, it gives us this one, isn't it? Yes. So yes, okay. Now what you are saying to me is correct. 100%. What you did is absolutely.
You see the way you have x minus 3 squared minus 2x. So my 2 was at the bottom there. So it was covering everything, then it being out. Then when I end up doing later, it will then come out. So which means
what 100%. Can we pack this for now and I explain it to the others at the end if we still have time? Because what you are coming up with is absolutely correct. If you does everybody in this group know what we call partial fractions? The rest of you guys, not the person that I was talking to. Does the rest of you guys know what she means by partial fractions?
Yeah, I know.
Okay. Right. So let's do this. This is very interesting. I didn't even check it. I just did this. I thought this one cannot be factorized. When this one can be factorized, then this other option of partial fractions, it gives you an answer that looks ridiculously different from what we have here. But if you take the derivative of this, you will find that. If you take the derivative of what the lady is talking about, you will still get exactly that. This is nice. You know, the good thing about maths, it's that you don't have to believe me, you have to believe the methods that I'm talking about. So when we finish this today, we will go remind me so that we can come back to this and we do it together using partial fractions, because this one can be factorized completely. Okay? But for now, let's do this one. Hopefully this one cannot be factorized. But if it can, you are welcome to do partial fractions. Uh, 3 minutes. 3 minutes, we get an answer. If we don't have an answer, we do it together. One minute left. I'm counting down seconds. 20. Five, 4, 3. Any answers? Okay. Let's do it together. Can anyone give me this with a version either as the denominator, sum or difference between two squares only, not the final answer? Anyone who managed to manipulate the denominator into the sum or difference between two squares? In other words, it's somebody that managed to do completing the square of the denominator. No one. So let's do it together then. Right. The first step, we have got a situation here that we have got the value of C, which is the constant, which is negative. So if we can isolate C now as it is, it will be minus 27. And our leading coefficient, which is power 2, will still be negative. And that is a problem because if you remember, when we do difference between two squares, our leading coefficient x squared must be having a coefficient of 1. That's why we take out, if you remember in the first slide, we had an A. That A could be any number. It could be a fraction, it could be a decimal, it could be positive, it could be negative. We take out that A so that x squared can be a positive 1 all the time. That's the trick with this question. So that is why in the first step, it is very important to take out minus 3 as a coefficient, as a common factor on the denominator. Move out minus 3. When you do that, what remains after you move out minus 3? You get an x squared minus 4x when you divide the positive 12x by minus 3, and a plus 9 at 27 at the bottom. Then because that 3 that you take out, the minus 3 that you take out is at the bottom, it goes out as minus 1 over 3. That's how we get to this stage. This is the key to solve this problem. From here, I think everybody can be able to go and then do the rest of the things. I'm not going to waste your time, but I'm showing you. Now, the next thing is to do that completion of the square. The minus 1 over 3 is outside. Then you isolate the 9. You put it outside. That's 9. And inside, you will be left with x squared minus 4x. Now, you need to add half the coefficient of x squared, or the square of half the coefficient of x. Coefficient of x is minus 4. Half of minus 4 is minus 2. Minus 2 squared is 4. So you add that 4 here inside. But there is no need for you to subtract the 4 because already you had a 9 with a 4 inside. So you just remove a 4 from the 9, put it inside this to have that. And what is left? It's a 5, which is that one. Or if you want the long way round, add a 4 here, subtract a 4 from the 9, and the answer is still 5. Then you have got that, which after that, then you can factorize. When you factorize the bracket, you get x minus 2 squared. Now, 5 is not a perfect square. So you cannot write 5 as any number that you know squared. So the question is that the number that should be written squared should be the square root of 5. Because if it was 9 that was sitting here, we would have written 3 squared here. If it was a 16 here, okay.
Please, sir.
Yes.
Can you please repeat on how you got the 5?
This 5. Okay, thank you so much. Right. When we complete the square is needed to be completed on these values. X squared minus 4x. The first rule that on completing the square, it says isolate the constant. In this case, our constant is 9. We isolate it. Now what is left is this x squared minus 4x. Then for us to complete the square here, we need to add half the coefficient of x squared, or the square of half the coefficient of x. Now the coefficient of x is -4. Half of -4 is -2. -2 squared is +4. So which is this, what you see here at the bottom? We take this and that, which are these two, add the 4. Then because of adding a 4, we have changed this expression. So to compensate for that, add +4 here, we must subtract a 4 from the 9. Add a 4 here, subtract a 4 there. So it's like adding 0. Add a 4 here, we get this 4 that we have added. Subtract a 4 from 9, we get 5. So what I said was the following. Because we need a 4 in here, and we already have got a +9, we just come to the +9 and remove a 4 and put it in here, which gives us that. And when we have removed a 4 from this 9 to get this bracket having a 4 that we are looking for, what are we left with from the 9 after taking out the 4? We are left with a 5. So if you can remove this bracket, we get back to exactly x squared minus 4x plus 9. Does this make sense?
Yes, it does.
Right. Now from here, it's a matter of just going factorizing to get that. And now, when we are at this stage, the -1/3 is not involved. Which rule is this one?
It's 25.
25.
Yes.
Let's see if we have checked the same rule. Yeah, there we go. Rule number 25. It says the derivative on top of f of x divided by f of x plus a squared dx is equals to 1/a arctan. Did I copy the right hand side correctly? Because I have got this tendency of mixing them.
Yes, it's correct, sir.
If that is the case, then there it is applied there. I just wrote tan inverse in this manner so that you can know that it is the same as arctan. Because there are a lot of people who will see arctan and they'll say, what is this? This is tan inverse. It's just the way of writing. And then our f of x is here. It's x minus 2, which is there on top. Our a is square root of 5, which is sitting here at the bottom. Now, already we had a -1/3 outside. Now we are supposed to bring in a +1/a. And this +1/a is the one that is bringing the square root of 5 here at the bottom. So you've got -1/3 square root of 5 tan inverse of that. Now, there are situations like this one that gives you a real problem. We had a situation like this before in a previous lessons. I don't remember which one, wherein we had something here, an exponential. When you do a derivative of every exponential, you will have this exponential as it is. But now the problem here is that the derivative of what is here at the bottom must always have an e to the power of 4x on top. But what we have here on top is not what we have here at the bottom. But then this e to the power of 4x can be written as this one, as it is, squared. So if this in brackets is e to the power of 4x and it is squared minus 2, can't we create a rule amongst those rules? Can't we create one of the rules so that we can be able to apply it? If the answer is yes, do it. Here, there's no need to complete the square. You just have to create a rule from the rule number 24 to rule number 29. Do it, it can be 2 minutes. You should be having an answer to this one. I'm counting down from 2 minutes.
Why am I on my own? It's just basic, just to get there. But discrete random variable.
Hey, hello. You are not talking about this one. Switch off your mic, please. 30 seconds left.
So my answer is -1 over square root 2 arc into e to the power 2x over square root 2 plus c.
Is it arc-cot or arc-coth?
Arc-cot.
Coth with an H.
Yes, sir.
100%. No, not 100%. That is correct. I have got the answer now. Anyone who has got a different opinion, because this country is a democracy. It's not like Burkina Faso. Burkina Faso, you hear what Ibrahim Traore is saying. If you agree with him, you just do it. If you don't, you move to another country. Here we get opinions. It's a joke. So hey, don't quote me on that. Actually, I like that guy so much.
What was the answer? Just to compare.
No, give us yours.
Mine is -1 over 2 square root arc cos.
Wait. Oh, 1 over 2 square root what?
-1 over 2 square root of 2.
Oh, 2 square root of 2. So which means it's coming from square root of 8, right?
It's coming from where?
2 square root of 2 is the same as square root of 8. Are you talking about 1 over square root of 2 only, or 2 square root of 2?
2 square root of 2.
Perfect. Then continue.
Let me start. -1 over 2 square root of 2 arc cos e to the 2x over square root of 2 plus
Arc
c.
what? Arc what?
Arc cos.
Cot is a cot with an H, right?
Yes, with an H.
100%. Then the number is in front. In front of cot. What do you have after cot?
In front of cos is e to the 2x over the square root of 2
plus c. Yeah,
plus
it
c.
means it looks like you guys are agreeing. So let's see. Now, whenever you get something like this and you realize that the derivative of the bottom gives you something on top that is a square root of what is at the bottom, like the derivative of e to the power of x will always have an e to the power of 4x. And e to the power of 4x is what you have there on top squared. Then you must always think, let me go to those integrals root 24 to 29. That is where you will get the solution. Only if you rewrite your question as what I've just did here. because now the top one, e to the power of 2x, remains as it is. Now the bottom one, e to the power of 4x, now is the same as e to the power of 2x squared. Minus 2 is the same as square root of 2 squared. I think that both of you who have given me the answer have done up to this step. Now immediately you have here, what you need now is a derivative of the inside of the bracket. This thing here is your f of x. You need its derivative to sit here on top. Now what is the derivative of e to the power of x? It is 2e to the power of 2x, which you see here in red. And the e to the power of 2x that was there, it is the same one you see here, but it was just missing a 2. Now this 2, you bring it so that it becomes the derivative of what is in here. Now because you have brought in a 2, you must compensate this by a half that you do outside. If you take this half inside, it will cancel out with this 2, and you will get back to exactly what we have here. And square root of 2 squared is exactly 2. So now you look for the rule, and you realize that it is rule number 27. Rule number 27, it says 1 over a arc cosh. So it looks like, are we on the same track here? Did you say cosh or cough? Or am I the one who has misquoted the rule here?
It's cost.
Is cost with an
is COTH. Remember here we don't have a square root.
Oh, this one has got a square root.
Root 27 has got a square root under.
Now you see 27. Hey, let me just check that thing quickly. Hey, I told you these things confuse me, and I know that there will be people who will be confused. You see, Kosh, yeah, you see, Kosh has got a square root on the left hand side, and Koth, which is this one, does not have a square root. So we need to fix this thing immediately. And these mistakes, I'm telling you, I went to the wrong one. This is the right one. So instead of the correct rule is rule number what?
29, sir.
It's 29, not 27. And on the right hand side, instead of kosh, is koth, right? With a T.
Yes.
And it's a minus here outside. Right?
Yes.
So which means is the previous slide, this one. Right. So which means here I miss a negative sign outside. Jesus Christ. And then I change this to a T coth, like that, right?
Yes, sir.
So can you see that I am here? I'm behaving like I know everything. I'm teaching you and I'm getting things wrong. You see, these things are supposed to be done with a lot of concentration. And I know that an exam situation is actually more stringent, like my situation. In my situation, I was preparing for this lesson for you. And then the pressure that I was having was almost 50% less than what you will have when you are sitting in an examination. So which means that for you to be able to avoid these mistakes that I am making, it means that you are supposed to practice these things over and over and over again, so that when you get to the exam, you even know these rules without looking at them. Unlike me, who is supposed to have to go and look at it. Even after looking at it, I still make mistakes. This is the second mistake, if you can remember. And I make the mistake from the first example. Just imagine you with that pressure in the exam. You have got those questions which has got 100 marks, and you have got 3 hours. And you are sitting there and they tell you that there is this invigilating app that is looking at you. If you move your eyes the wrong way, they may think that you have got someone that is telling you some at some other place. I hope Dr. Dlamini has explained to you that how it works during the examination. So you are under a lot of pressure there. So for you to be comfortable, you must have done this over and over and over again. I know I was a marker before. I used to mark assignments. We would find in 100 assignments, there's a group of 30 assignments that look exactly the same, another 30 that look exactly the same with the same mistake. So when a person do you see this mistake that I've just done here, if I was maybe one person that I'm saying, send me your assignments, I want to write for you, I would have got this question wrong, this one that we're having, because I would have quoted the rule that has got a square root, while this one does not have a square root. All people that write the assignment from that particular guy will make this same mistake. And in mathematics, it's impossible for two people to make the same mistake at the same question, at the same place, at the same time. It's impossible. So we know immediately that you have copied. So to avoid that, you need to go and do those questions in the study guide on your own. You need to go and do the assignment on your own. When you get to the exam, you will be working very freely. Right. So this one does not even have my thingies. Oh, it does. I didn't do a slideshow. Right. There you go. 2 minutes, because this is very straightforward. Do it. It looks like a trig question, trigonometry. It involves trigonometry. As I have said from day one when we dealt with integrals, it means that for you to be able to be proficient in integration, you must be a star. You must be a superstar in derivatives. So if you know your derivatives, you can be able to sort this one out. Let's go. 2 minutes, because it's so easy that when we do it, you will realize, for those that will not see how to go from here. 2 minutes from now.
Answer is
Yes.
arc sine of tan x over 3 plus c.
Arc sine with an H, right?
Yes.
All right. So we've got sine inverse, sine with an H inverse of tan of x all over what?
3.
All over 3 plus c. So let's get other opinions.
Correct, sir.
So you are seconding the answer that was given. Right. So it means we are on the same page. Now, this 1 over cos squared was hidden. It's actually the same as if you take cos squared up, it becomes sec squared. Now, this sec squared, if you isolate tan x and you have it at its power of 2 outside, the derivative of tan x is sec squared. That's the only trick with this question. So if you don't understand your derivatives, you will never be able to find the way out to this question. When you are at this stage, then you go to and look at the rules. The rule must be, on the left-hand side, it must have a square root, and it must have an a squared plus an f of x squared. Did I quote the correct one here? 26.
Correct, but 26 on the right hand side doesn't have 1 over A.
So on the right hand side is supposed to be just axing.
Yes.
Yo, can you see? I'm creating my own rules now. This is the Kone rule. So let's fix it. So you are saying, according to rule number 26, let me just go and make sure that we are on the same page. I'm not saying I don't believe you. I just want to make sure. 26. Ah, there you go. It does not have a 1 over. So there are 3 rules that don't have a 1 over. And you know, I'm creating my own rule. So I will be a genius in future. I'm telling you. In future, I will be a genius. I will have a PhD in creating rules. There you go. Then we must remove the 1 over that, which means also here. And for a change, I wrote arc and arc there. I was supposed to, according to what I was planning, to have written sin inverse, but I will leave it like this. So you are saying that now this is the correct answer.
Correct.
100%. You see, we are winning here. We are winning so perfectly. So this is how it works. And then this one. Now, just a hint before you start with this one, my good people. The problem is now there's an X on top. And this X is the one that we were looking for to use rule number 2 and rule number 3. So the only problem that we have now is that the derivative of what is at the bottom, it's actually 2x plus 6, not 2x plus 3. So it means that there is something we can do to the numerator without putting in an x which was not there to create a derivative of what is at the bottom. So that is the hint that I will give you. Something that you can do to the numerator to create a derivative of what is at the bottom. Whatever you do on top, it must not change this integral. So whatever you need to compensate this 2x plus 3 that is there on top for it to look like 2x plus 6, when you compensate for that change, it will create 2 integrals for you. Do those 2 integrals, and this is going to be a little bit challenging, so I'll give you 3 minutes, not 2 anymore. So in 3 minutes, I will be expecting a very beautiful answer. And hopefully the denominator cannot be factorized. Let me just check. No, it can't. Because for you to get a -5, you need different signs, and you can never get 6x from that. So if it was x squared plus 6x plus 5, then the story would be different, because 6x squared plus 6x plus 5 can be factorized. So we can use those partial fractions that I promised that we will show you how to do it after we finish all these questions. So go on and get me an answer. Now, 3 minutes, please. No. One minute. Time is up. Any answers? I guess that this will be a little bit hectic, but can we do it together? And the first step, as I have explained, let me do it again before I show you the step. Because of the fact that we've got an X on top, there should be a way in which we can connect the top with the derivative of the bottom. Now the question is, what is the derivative of the bottom? The derivative of the bottom is 2x plus 6. But what we have there is 2x plus 3. So this 3 need another 3 for it to be a derivative of the top, the bottom one. But by virtue of us adding a 3 on this 3, we need to subtract a 3, which will give us a new dimension to this question. So we'll have a 2x plus 6, which we are looking for, and a minus 3 that will be there, which I'm just showing you right now. So the 2x plus 6 that you see, which is this part here, this part is the derivative of the bottom one. So here we can use rule number 3 for this part only. But there is still this part that will still have this denominator. That is why we will have a situation like this. Now, let me explain this situation. It says we've got this 2x plus 6 divided by this denominator, which is that part, minus this divided by the very same denominator, which is represented by this part. What I just did is to take the minus 3, which was supposed to be sitting here, outside, because it has got nothing to do with what we will do here. So this minus 3, we can put a plus sign here, take this minus 3 inside so that you can see it exactly like that. It will be this, which is this part, divided by this denominator, and then plus this inside, it becomes minus 3 there on top over the same denominator. So if you put this together, you get back to this. If you put this together, you get back to that. So up to here, there is nothing magical with it. It's just normal arithmetic manipulations. Now, this part, because of the fact that this has got this as its derivative, there's a rule number 3 that we will use. So we would, for now, forget about this one. Just leave it until we apply that rule. Now we come to this one. As I have said at the beginning, if this denominator can be factorized completely, then we can use what we call partial fractions. For now, we can't, because this cannot be factorized completely. But if this was a plus sign here, things like this, we can do them without using rule 24 to 29. We can use what we call partial fractions, which we are going to try and do at the end of this lesson today, with that previous example that had a denominator which can be factorized. So, but for now, we'll leave it for later. But because of the fact that this cannot be factorized, so we are going to use completion of the square here. Remember, completion of the square means isolate the constant and have the coefficient of x squared to be positive 1. And that is what we are doing here. This one is the same thing as it is. We just copied it down exactly. The minus 3 comes down. Now, completing the square here entails taking a coefficient of x, which is 6. Half of it is 3. 3 squared is 9, which is this 9 you see here. So these two are accounted for here. And the 9 that we have inside here is found by taking half the coefficient of x and square that, which gives us the 9. Now we had a minus 5 sitting outside alone there. Because now we have added a 9 plus 9 here, we must compensate it by subtracting a 9 from this minus 5. Now minus 5 minus a 9 gives us this minus 14 that you see here. Now we have got a situation where we can factorize this and have a perfect square, and this one can be written as a power of 2 in this manner. This I just copied it exactly as it is, but just turned this 2x plus 6 in red so that it can show you that it is the derivative of what is at the bottom. Rule number 3 here applies. So go to your integration rules, look at rule number 3, how it works. And now after you are satisfied with how rule number 3 works, come to this one. The minus 3 is the one that is coming down from the beginning up to here. Now, the derivative of x plus 3 is 1, which is the one in red. F of x is x plus 3 squared minus square root of 14 squared. If you take square root of 14 squared, you still get the 14. So this is the difference between two squares. It does not have a square root. It has a rule there that you can find. So can you please tell me the rule that we need? Because I know that this is rule number 3. What rule can we use for this other integral? Check.
27.
Rule number 27. Can you check if
Yes,
I've
sir.
applied it correctly? Because I didn't write it down this time. I thought I was so confident with these rules that I don't really need to write them down at this stage. So can you just correct me if I'm right or wrong? Did I apply it correctly?
It is Akkosh, sir.
It's not Akkoth.
No.
It's Akkosh.
Your
So
answer is correct. The answer
the
is
rest
correct.
is, come again?
The answer is correct.
So where is this Akkosh coming from?
Sorry, is it 27 or 29, provided there's a square root of 14?
No, there's a square root of 14 here, which is from this part. So I
Yes.
don't remember the rule. I just thought I'm now, I was, you know, when you feel that you are in the groove of things,
No,
that is
you're
how I
correct,
felt.
sir.
I was on the groove.
The answer is correct.
Yeah. So which rule is this one? Because I don't remember.
Rule 29.
That should have been 29. Yes, I agree with you there.
Yeah, it's
So it's
correct,
rule
sir.
29, and I have applied it correctly here, right?
Yes.
Yippee! I'm a star. You should be clapping. Right now, I want you, because here I have actually given you a hint and you were not able to come up with these things that I'm showing you. No hint now. Do this one. Similar question to the previous one. It has got an X on top. So that I'm fair, 4 minutes now. 4 minutes. You must do from scratch, connect the numerator with the derivative of the denominator, and have that other thingy. Do the same way as we did the previous one until the final answer. And then 4 minutes. The counting down start now. 3 minutes gone. 1 minute left. Any answers?
Let me try, sir. I
Yes.
think it's half ln into 8x minus x squared plus 9, close bracket, minus 1/5 arc cot into x plus 4/5, close bracket plus c.
Cot is a T with an cot with an H.
Yes, with an h.
Okay. Anyone with a seconder or a counter? Anyone with a seconder or a counter? None. So let's do it together. There we go. Now, the first part is to get the numerator to contain the derivative of what is at the bottom. Now, the derivative of what is at the bottom, let's look at it from the beginning without brackets, where we still have the original question. The derivative of this thing is 8 minus 2x. And what we have here is x minus 1. So we need, firstly, the change of sign. So there must be a negative sign that must move out of here, so that this becomes 1 minus x, so that we get the minus 2x first. So when we factor out the negative sign, that is where we get this minus sign that you see here. Then another thing now, when we have this as 1 minus x, it must be 8 minus 2x. Then immediately we write 8 minus 2x. So for 8 minus 2x, to get back to this x minus 1, we need to multiply, to divide each and every value here by 2. When we divide this by 2, we get the minus x. But when we divide this by 2, we don't get back the 1. We get the 4. Now, what number can be subtracted from 4 to get 1? That number is 3. But remember, that number 3 is going to be subtracted from a number that has a half that was factored out. That is why that number has to be a 6. I think for you to understand this, we can put it this way. Before this multiplication by half, let's get this minus half in here on top. When we multiply this half here on top, this becomes a minus 4. This becomes a positive x. this becomes a positive 3. Now, positive 4 minus 3 is a 1. So if we ignore the half, the negative, and we multiply this by a half, so half times 8 is a 4. Half times 2x is minus x. Half times minus 3, minus 6 is a minus 3. And 4 minus 3 is 1. So this on top is just this with a minus 1 taken out. So what we needed was an 8 minus 2x. That's why we have to have each and everything inside. That is a 4 before the half comes into play, a 4, a minus x, and a minus 3. All of them must be twice the values that we will have had if we are not talking about this half. So this half is coming to compensate for that. So now if you check 8, okay, yes, Franz Abram. Please switch on your mic and speak. There was a hand. I recognized you. Please switch off your on your mic and speak.
Can you hear me now?
Yes, perfectly so.
Okay, thank you. I just want to find out from you, sorry to disturb you. I just want to find out from you if are we allowed at all to maybe like change the denominator, maybe rearrange it into minus x squared plus 8x plus 9.
Yes, you are
Or
allowed
we
to
have
do
to
that.
deal with what we have.
No, you can rearrange. It's just that we don't really deal with a leading coefficient with a negative sign. It doesn't matter. That is perfectly fine.
Okay, cool. Thanks.
So that now what he is saying to everybody is that if this was rewritten as minus x squared plus 8x plus 9, then the derivative of that will be minus 2x plus 8.
Yes.
Exactly. Yes.
And therefore we would have minus
which is
2x
this
plus
one just
8.
Which is just this one when you write it the other way around.
Yes. And with a plus 3x minus 9 at the top.
Come again?
Okay. No, I was saying it will then be minus 2x plus 8 plus 3x minus 9. But it's fine. Let's continue with yours, sir. I will do this one also on the side and see if it gives the same outcome.
It gives the same result. But
Yes.
is everybody happy with what we have? That this is exactly the same as that? Because that is a paramount important thing that we need to agree. Because what we have at the bottom is actually this 9 as it is. There's no change in signs with the ones at the bottom. The 9 as it is here. Then what we did was just we factored out only the minus sign from this one to get to this. But this is actually not really necessary for this part. It is necessary for our completion of the square. But this part here, the first part, is the derivative of this whole thing that we have here.
Sir?
Yes.
If I may ask this one, is there a reason why we specifically took out that negative sign as a common factor for the x squared minus 8x on your first step denominator?
Here.
Yes, because it looks a bit complex now with the negative on the outside and then that negative. I'm looking for the derivative of
right.
x squared minus 8x, which would have been 2x and minus 8. But at the top, we're sitting with 8 minus 2x. I think maybe we could have avoided that step.
This step
I don't
here.
know.
Yes. No, you are right. You are right. This step can be confusing because now the derivative of this cannot be really connected with that exactly.
Exactly.
Because the derivative of this actually will be 2x minus 8, but with this minus sign it becomes that. But yeah, I could have avoided this, and let me just do this now. Let me go out of this and we look at this question completely without slideshow.
Okay, I'm
Right.
really sorry. I hope I'm not messing your system around, sir.
No, you're not. You're not, definitely. Because what I did here was to prepare for this part. So what you were saying is, okay, let me get back because what you are saying has been covered in the next slide. Right. So what you were saying is that if we could have left it like this without doing that here,
Yes.
yes, and then it means that we can only do it on this other part.
I think that would make
100%. Let me put it back. And you are absolutely right, because it can be very confusing to some people, because why do we have that version now and now this other one? Let me just correct this thing. It's not wrong. It's just that it is premature, if I can put it that way. Yeah, you are 100% right. There you are, spot on. So this is what you were saying, and let me do the slideshow back, and then we get right. This is what you were saying.
Yes.
No.
Provided the negative already is taken out, accommodated on the negative one.
No, I made a mistake. So let me just put the negative back in here and the plus there. And the 9 is there. Right. Then we'll get back to the slideshow. And then the 100%. So this is what you were, yeah. So you're absolutely right. So this is the same thing. It's just that the other one was bracketed and there was a factor out of a minus sign, which complicated things. So I will now get back to the explanation that I was having. So now the derivative of this thing at the bottom is minus 2x plus 8, which is this one here on top that we have created for. And this minus 6 is compensating this 8 that we have brought in, because when you multiply this minus half inside here on top, you get minus half times this 8, you get a minus 4, minus half times minus 2x, you get an x, minus half times minus 6, you get a plus 3. Now you've got a minus 4 plus a 3, that gives you a minus 1, which is this one. And you've got a minus half times a minus 2x, which gives you a plus x, which is this one. So this is exactly the same as that. Now, the next thing is now to separate now the derivative, which is 8 minus 2x, which is this one here. And now its denominator, which is exactly the same as that, we just start by writing the positive 1, which is 8x. So this and this is exactly the same. Is the 8x, the minus x squared, and the plus 9 there. Its derivative is what you see there on top. Plus now the minus 6. Now this minus 6 was supposed to be sitting here on top. It has got the minus half that was outside. The negative and the negative of the 6 becomes this positive. The half outside is still this half. This 6 is from this minus 6 is there. And now this version is exactly this after we isolate the C, which is the 9. Then what we did was to take out a common factor of a minus sign from these two. When we take out that common factor of a minus sign, we get x squared minus 8x, which is this one. Right, so from here, if we can connect this with what we have before, the next thing now is The minus, this one is coming down as it is. There's nothing we are doing here because we are ready for rule number 3. We are ready here for rule number 3. Now, this one is the one that we need to create either rule number 24 to 29. And we do it as follows. The 9 was here, is the one that we already had, this 9 outside. And we have factored out the minus sign from there to get that. Now we need to complete the square here. And then we ask ourselves, what is half the coefficient of x? The coefficient of x is minus 8, and half of that is minus 4. And minus 4 squared is 16, which is this 16 that you see here. So x squared minus 8x plus 16 is there. And so we have added a 16 inside here. But when we added this 16 inside here, there's a minus sign outside. So we have added a minus 16 really here inside. Because of the fact that we have added a minus 16, we must put a positive 16 on the 9 to get this 25. So if to check if this and this are the same, you can remove this bracket. So it will be 25 minus x squared plus 8x minus 16. And 25 minus 16 is 9, which is this one. And these two are exactly the same. So this is just a little bit of a tricky play with signs, which you should, at your level, should be able to do. Now, the next part. You see now here, there is something wrong here. You see, now the minus half is not there anymore for this part, which is wrong. The minus half here is still there, but here it's not there. I can be able to explain the half this side. So I was doing, yes, Mahato.
My mic is bad. Hopefully you can hear me.
I can hear you. Yes.
When you first separated, when you from the third step.
Okay, just tell me to stop at the step you're talking about. This one.
After this, I don't know, after this one. Here, this plus
this one.
Half. Wasn't it supposed to be minus half?
Oh, yes. I have explained this. Let me do it again. This is minus a half, which was supposed to be minus here. But then we've got a minus 6 that was supposed to be sitting here. So this minus half and the minus 6, if you take this negative out, it becomes positive.
Okay.
Does it make sense? Yes. But there is something that does not make sense to me after this step, which is the same thing that we see here, we see there, right? And then this a half multiply, if you can take this 6 out, actually, it becomes 6 over 2, which is this 3. And you are left with a 1 there on top, which is this one. Now, in my next step, this is where there's a mess up here. Because this minus half is not there anymore. So what was in my head when I was doing this next step was what I did here with the half and the 6, and I got a 3. So I don't know what I did with this minus half because it was supposed to still be there. Can I get back and correct this now? Because this here is supposed to have a minus 1 over 2, like that. And which means that this one must have a minus 1 over 2, like that. And the rest is 110% phi. Right. So after this step here on top, we've got the derivative of this. So it means that because of the fact that this is the derivative of that, rule number 3 says because this is power of 1 as it is, when it goes up, it becomes power of minus 1. We have to apply ln of what is at the bottom because it is accompanied by its derivative, which is that. the minus half, which is this one, same thing. And then with this part, which rule is this one? Can you confirm that before we continue? Because I said it's rule number 28. Can you confirm if that is correct?
I second you on that, sir.
28, right?
Yes. I don't know about others, but
Is there anyone who has got an objection with rule 28 here? Because I'm not always right. You have seen my mistakes here.
Yes, it's correct, sir.
100%. So then this is the answer. How did we get 3 over 5? You can go to rule. This rule says 1 over a. This one has got a 1 over a. And then the a is 5. Because from the 25, it's 5 squared. 1 over 5 times 3 is 3 over 5. Arctania is, and then the f of x is x over x minus 4, all over 5 plus c. And we're done. Now, I said we will do the partial fractions. And I have to run to a very quick errand. I don't know if the lady that had that partial fractions on what question was that? Which question was factorizable? That we had where there's a is this one, right? Can I get a confirmation of this, please?
Yes, sir, it's that one.
Is this one?
Yes.
Are you part of the people that were given the right to be presenters?
No, the one
Are
who's
you?
asking is not that one.
It's not you.
No.
So hey, I need to quickly run to some place now, and I would have loved to do this question using the partial fractions, because I know that it can be doable and the answer that you gave is correct, but it doesn't look like this one, so that people can get that alternative solution. Right. So can we do this now? Is there anyone here who has got a problem with partial fractions? Who does not who does not know what partial fractions are? Anyone? So everybody knows what partial fractions are. Then it means that you can do it. Then I can have a look at the solution. I have got time. I will quickly run to this errand and I will leave this thing on. And you guys will do it using partial fractions, and we can do it together when I am done with the errand. Or I will be online. We can be discussing if you have answers already. So let me give you a hint here for you to use partial fractions. Factor out the 2 first and the 3. So you will have 3 over 2 outside. Then what is left inside is x squared minus 6x plus 5, which can be factorized. So can you please do partial fractions elsewhere and give us the equivalent of these integrals in this form? It will be after you factorize. Where is this normal integral here now? It's not there. Oh, there you go. So we will have, this is what we will have. So this is what you are going to do while I will be doing my errand. I will be driving, but I will be online and you will be doing it. And as soon as I stop, then we can do this thing. So I want you to give me the value of a the factors here will be x squared plus minus 6x plus 5. So it's x plus x minus 5, right? X minus 5 dx plus 3. Those that are not interested can leave. It's fine. If you are not interested, we are done with our lesson. So those who are interested can remain and we can do this together. Those that are fine with this that we did today, our lesson is done. So if you are interested in doing this, you can remain and we can do this together. So I just want to finish this partial thingy here. Okay, let me just copy this then and put it there at the end. I like that. So the other one is x minus 5 and x minus 1, I think. B here on top. So can you please do partial fractions and let me know what are the values of A and B? Quickly, please. As soon as you get these values, I will be available online. You will let me know what the values of A and B are. And then we can take it from here. So is there anybody who has got a question with what we have on the screen now? Everybody's happy. So what we did here is that we have taken out the 3 and we factored out a 2 at the bottom and we remained with x squared minus 6x plus 5. And x squared minus 6x plus 5 can be factored into x minus 5 into x minus 1, which can be done as partial fractions. And the partial fractions will look like what you have on the screen. So can you please go to do partial fractions and get back and give me the values of A and B. So as soon as you get those, you let us know and we will add them on here and we will update as I'm going. So you guys, please do the A's and B's, and as soon as you find them, let me know. The first person to get A and B, please let us know. Values of A and B, as soon as you get them, please let me know. Anyone with values of A and B? Hello? And then you can think that you are still having people and you are alone.
We're still here, so just we're just looking at it deeply. Maybe we're even overthinking it already.
They are still busy with partial fractions. Perfect. Okay. As soon as you get videos, please let me know. I will plead with you. After we are done with this, the answer will look very different from the answer that we got in the initial question that we did. The lady that gave us this answer has done it this way. So I would like you to go and find derivatives of the final answers in both cases and see if you don't get the same integral that we had at the beginning, this one that we are having here. So it shows you the beauty of mathematics, that there can be 5 different answers that are done correctly, but they don't look the same, but they are correct, all of them. It's possible. So here today we have 2 that will look very different, but they are all correct. So don't mind. I'm coming to pick up my wife. She was doing hair. So whoever will be talking now with me will be my wife. So you don't have to worry. The class should still go on. So when she thinks that I'm doing girlfriends, she'll know that I've got a lot of them, and you are those ones. Yeah. So she's about to arrive, and then I will be going with her home, and we will still be doing our finalization of our question. And when she comes in, you can say hello. But just it must end there. With guys, please. It must end at hello. Yeah.
Where else?
I don't want problems.
Where else would it end?
Yeah, you guys, I don't trust you. You see, I don't like problems.
We don't want peace either, say.
I know you don't like peace. You don't want peace. Yeah, I don't like I like peace. You guys don't like peace. Hello. Since here you can say hi.
Hi, ma'am.
Hello.
I told them that I'm coming to pick you up.
Oh,
How
Yeah.
are you, ma'am?
I am good.
I said you must
How
just
are
say
you?
hi only. You see, now I don't trust you guys now anymore. Any values of A and B?
I don't know. I'm looking at 3/2 for both of them. Feels wrong though.
3/2 is the coefficient that we have outside, so it has nothing to do with the values. I'm not sure. I don't even know the values myself. So the lady who did it this way, can you please be the adjudicator? The lady who did this method, can you tell us, do we consider those values of A and B? They are not wrong yet until we prove them otherwise.
Yeah.
Is the lady still available? Who did this method? It looks like she's gone. Hello, guys. Are you still with me?
Yes, still yes, sir.
Oh, okay. Right. Is there anyone with different values of A and B except 3/2? Or anyone who is seconding 3/2? So no one is doing anything except the person who has given values. So it means that we are supposed to do this together. In the next 2 minutes, I will have arrived back home and we can do it together. It's fine.
Sorry, sir.
Do you have an answer?
Yes, I think I have a different one from the previous speaker. A, I got
Yes.
1/4, and B
A is 1/4.
Yes, B is -1/4.
A is positive 1/4 and B is negative 1/4. Okay, it's fine. Then we've got two opposing. We have got two factions. Is there a third one? No third one. So we must do partial fractions then. Okay, let's do it. I have to get out of this so that we can have a blank. Yeah, web black.
Sorry, I want to go
Blank,
against my
what?
word. I think A
Yeah,
is
changing.
2. I think it's 2/3, and the same thing will apply to B.
Oh, A is 2/3 and B is 2/3.
Yes, as opposed to 3/2.
2. Oh, okay. All right. So then what we do here now is that we have our 3/2, and then in brackets we want to isolate the numbers and have our quadratic expression as it stands. How do we do this? That put it in brackets and in a fraction which is 1/the factors. So it will be x squared minus 6x plus 5, right? And then we factorize it completely. So this will be 3/2. And then this one factorized completely. Will be x minus 5 into x minus 1, right? Are we happy with that now?
Yes, happy this side.
So that now, yeah, so that now that integral that we were working with, which is this one, before the integral, let's Yeah, let's just stick with the Word document. So now we're going to let this fraction, we are leaving 3/2, we'll bring it back on later. So we're going to let this be equal to partial fractions, which is a over x minus 5 plus b
over x minus 1.
Yeah, b over x minus 1. All right, then we multiply by the LCM of the denominators, both sides, so that we have. Can you guys still read what I'm writing here, or is it too small? Should I increase the font?
I can see.
That.
I've got very big eyes.
Is it fine now?
It's fine, sir. I don't know.
I was thinking that it was too small.
That's fine.
So
Sir.
others, maybe when you are watching when you are looking at on the phone. So we're multiplying by the LCM of the denominators, everything. So the left-hand side will be 1. So the left-hand side is 1. The right-hand side will be a into x minus 1. Right?
Yeah.
Plus b into
x minus 5.
X minus 5. Then there are a lot of different methods that people can use here to solve for a and b. You can do simultaneous equations, which takes a little bit more time, by multiplying out and group those that have got x on one side, those that are constants on the other side, and do simultaneous equation with a and b and find the values. But you can cut it short by elimination. You can let x be equals to 5 to eliminate b.
Yes.
Right, so let's do that method. Let x be equal to 5. Then when we do that, we will have this equation now becomes
1 equals.
We put 5 here. Minus 1 is a 4a, right?
Yes.
So this becomes 4. Yeah, this becomes 4a. Then this becomes a 0 because 5 minus 5 is a 0, right?
Yes.
Then it means that indeed
a is 1 over 4. Yeah.
a is 1 over
right.
4. So those that have given a as 1 over 4, they were right.
Nice.
Perfect, right? Then we do the same. We will let x be equals to what now? To cancel out a. We will let x be equals to 1, right?
1, yes.
Yeah. Then when the left-hand side will still remain 1, and the left-hand side will still remain 1, and then when we put 1 here, we get a 0 here. 1 minus 5 is minus 4. So b is
negative.
Is minus 4b, right?
Yes.
Minus 4b. Therefore, b is negative 1 over 4. So somebody has mentioned these answers. So then now we can go back. Now a is 1 over 4, b is minus 1 over 4. Then we can go back to our slide now, and a is positive 1 over 4, right?
Yes.
Then it's 1 here over 4 here. 4 that we can put here. We can take out here, and this can become 8, right?
Yes.
Same applies here. B, what is B? Is negative, right?
Negative, yes.
So then it changes this sign here to become negative, and this becomes an 8 as well.
Yes.
Do we agree?
Yes, I agree, sir.
Anybody else who disagrees? Okay, what we did was we found that A was positive 1 over 4, put 1 over 4 here, the 1 will remain here, the 4 will come down, and we factor it out into the 2 that was there, becomes an 8. Here it was negative 1 over 4, the 4 which was here at the bottom, factor it out to become multiplied by 2, it becomes 8. The negative sign becomes negative out there. So this is what we have as a partial fraction of what we have there on top. And now this is rule number 3, because the derivative of x minus 5 is 1. The derivative of x minus 1 is 1. So which means this is actually equal to, if we can just, so that I can use the equation editor, I can just put it back here. And this is the same as, now we can remove the derivative, and this is the same as ln of the one at the bottom, x minus 5. And the same applies to the second one. The derivative of x minus 1 is 1. So this is the same as ln of x minus 1. And I think the lady gave us this after she applied log laws. Because if you can factor out this 3 over 8, if I can just copy this and put it back here, and well, undo. I didn't put it at the right place. So let me just do this, put it back here. So if we can factor out the 3 over 8 on this one, let me just give a space so that we can see properly. Let's do smaller space like that. This is fine. All right. So in the next step, we're factoring out 3 over 8. So that we have got, say, let's use these brackets. And this 3 over 8 is gone as well. And then we'll close this bracket out there at the end, like that. So we have factored out 3 over 8. Now, that lady gave us an answer like this one. She says it's 3 over 8. And then, because of the minus sign in between, you can write one ln. Yeah, then you can divide. You can say
x minus 5 over.
Yeah, you can say x minus 5 all over x minus 1. So this is what that lady gave us as the answer, plus c, right? Plus c. This is what we were given. You can see that this answer, it looks way different from the answer that we get at the beginning. So what I want you guys to do now for me is to go and find the derivative of this one. Ne? Find an answer which is the derivative of this one. If it is not this one, then it means that something is wrong. And then you go back to which slide was that? That has got this same question. It's an earlier slide, man. It's an earlier slide. It's not this one. It is not this one. Oh, it is this one. Yes. Right. So I will. How do I do this slide so that you can remember them? Let me do the background, some background. How do I do that?
Or maybe you can copy it into the chat, sir. Into the chat, I meant to say.
Let me just try something before we can try what you are saying, so that I can. I want to do something so that you can know which slides you're supposed to compare. Aha! You see, the background is green. This is what I wanted. So we can do the same background here. So I will send out these slides so that you guys can go and check these green slides, find the derivatives of the final answers, and then check if they are different from the original integral. How about that? So that's I've saved that slide. So we are sorted for today. So what I will do, I will send. In fact, after you guys leave here, this thing will be saved. Then I will send the slides to Dr. Dlamini. She will share all those with you. And when you see a green slide that has got a background of green, go and find derivatives of those final answers and check if they are not the same as the initial integral. And this will bring us to the end of the day. And it will only stop when Lilaka Kucho, Elias, speak, because his hand is up.
I've got a question. I'm not against the last method. I just wanted to know what will the question be saying? Will the question be saying integrate or solve the integral? Then that's it. Or will it be specific to say use inverse functions or?
I know the question. When they said the exam, especially the exam, they don't tell you which method to use. They will just give you an integral and say solve for the following integrals. If you check the past, do you have access to past exam question papers?
Yes.
Yeah, you can go and check the kind of questioning that is there. They will not tell you to use a particular method. What they can give you is when they realize that maybe it's a tricky question, they will give you a hint. So a hint will come in a situation where maybe there is no two possible methods, it's only that one method. Like when you have got a denominator that cannot be factorized at all, then they may, I don't think they do that. They could, so I think when they don't tell you the method. I've actually marked exams before as well. I have never, when they give you a hint, is to make you to make you go to the particular rule quickly. So I think usually it will be an open question that will make you decide which rule to use. So you don't have to be constricted about a particular rule.
Okay, no, it's fine because I.
Do you have a rule that you prefer between the two?
No, not necessarily. I've got a rule that I prefer. I just wanted to remember we are in inverse functions. So if you are diverting to do a certain technique, which is outside of what we are covering, but since you have said they don't specify which technique then it's fine.
Yeah, if you look at the unit, the way that I named this unit, because I realized that it is not actually, the unit itself is not called inverse functions. The integral themselves become inverse functions. So it is not, there's no, even go to the study guide, you will realize that even the person who has prepared the study guide didn't write that we are finding integrals of inverse functions, because that is not true. The integrals themselves they lead us to inverse functions as the answers. But they are derivatives of inverse functions. Am I making sense? Am I making sense?
Fine. Yeah, no, it's fine. I just wanted to know if it's good to know that we won't be penalized for.
No, you won't be penalized for using any method. So what happens with the exam marking is the following. Né? We may not even know ourselves, like I did with this preparation. I didn't know that denominator can be factorized completely. When I worked with, because I was my concentration was on applying all those rules. You can see in my presentation today, I have covered all the rules from 24 to 29 in all those examples. I just made sure that I must cover each one of those examples. But only the lady that told me that she has got an answer as lean of this over that immediately it clicked. If you remember, I went back and said, hey, can this be factorized? So I realized indeed it could be factorized. Because whenever a quadratic can be factorized, there is no need for you to complete the square. You do partial fraction. So it was a very profitable mistake on your part as students for me to have a denominator that can be factorized in this particular lesson.
All right.
Yes. Any other question, suggestion? Oh, and then another thing, this is the first time that we did an example that was in the book. So we must continue the way we have done it today. Going forward. Are you happy with that? If you're keeping quiet, you are saying yes. Goodbye. Go now. Bye-bye. Have a good evening, and be careful during the long weekend. I want all of you next Thursday intact in one piece. Bye-bye.
You will be studying during long weekend.
Yeah, don't do what I won't do.
Bye.
Cheers.
Sharp. Okay. Bye-bye. Kalonji, please go. Mahlatsi, Ari. Wista, please leave the. Yes, bye-bye. Mahlatsi, Ari, Tsamaya. Hey, Mahlatsi, you're the only one left. And if you don't go out, then this recording will not stop. Yeah. Hey, Mahlatsi, if you are hearing me, please leave the Microsoft Teams meeting of UNISA. Because if I get out and you don't stop, this will not stop. It will not record. So can you please get out? Hey, Doc. Hey, we finished some minutes ago, and there is a person who is not leaving. And you told me that I can remove this person. Where do I go? Where do I go?
To the name.
To the name of the person.
Yes.
Yeah, and then those 3 dots. Yeah, yes. There's no option. That's the problem. The options that are there is mute participant, disable mic, disable camera, pin for me, spotlight on everyone.
Let me see.
Yeah, please get in and remove this person because this thing will not stop. My shots, you see them? Oh, AI is gone. He's gone. He's gone. Oh, yeah, I was not having those powers. No, yeah, because if I was told that if Microsoft Teams, there's one person that remains there, and this person is not removed or it does not leave, this recording will not stop. It will just go on indefinitely, and so it means you will not be able to download it.
Let me stop the recording. Yo.
Yeah, yes. When I leave, it stops. If everybody leaves, so I'm going to leave now.